Okay. So we're starting a new unit and we're going to cover the exact same four things that we covered in unit 7. How to find a confidence interval one sample, how to find a confidence interval for a difference of samples, how to do a hypothesis test for one sample, and how to do a hypothesis test for a difference of two samples. Except instead of proportions now, you've got to change your thinking. We're doing means. Okay? Those are sort of the two big areas where there's lots of statistical problems, where we're dealing with the proportion of people who favor something or who prefer something. And then there's another large group of questions that involve the average of something. Okay, so remember, we're thinking means now, not proportions. So we're not thinking little p or little p hat or p null. We're thinking x bar and mu. Okay. So we're going to start off with a confidence interval. Well, you're ready for a confidence interval. It's point estimate, and then we've got a margin of error above and below, right? And we talked about sort of the long way of calculating that using a z-score and then multiplying that by the standard error. And that sort of becomes our margin of error. We're going to do the same thing with means, except we use slightly different formulas. So the example we're going to look at, do social media creators on average make a livable wage? Well, it seems that these three do. Okay. So how is this determined? So whoever was doing this confidence interval, I guess, or doing this study, they searched how much I make on YouTube, found hundreds of videos of which YouTubers showed off how much they make on the platform. So out of all of those, 35 were randomly sampled. Okay. And then from the figures shown in each video, their estimated yearly, their yearly salary estimated. And since the video showed their private channel revenue pages, we know the data is reliable. Okay. So that's what we use. That's our sample. Now remember, we want to be able to sort of take a sample and generalize it to the population. That's the whole goal here. Okay. So the population mean used, that's the parameter, and that's the mean salary among all YouTubers. That's what we're sort of trying to state. You know, we want to, but we can't do all of those videos. You know, it'd be way too time consuming. Plus there's some other issues as well that we'll talk about. Okay, so we take a sample and we find the average in that sample, and that, because it's a sample average or a sample mean, we use X bar, and that's referred to as a statistic. So back in unit 6, we talked about, like, remember unit 6 was you were given information about a population, and then we calculated information about a sample, which is great, but it's normally the other way around, which is what we've been doing in unit 7 and what we're doing in this unit, where we don't know stuff about the population. We want to make an estimate about a population, so we take a sample. But we did use this, okay? That for a sample mean, as long as certain conditions are met, and we'll talk about those conditions in a second, very similar to conditions for proportions except for one. To find the average of the sampling distribution, that would have been the average of the population. To find the standard deviation of the sampling distribution, we would have done a standard deviation of the population divided by the square root of the sample size. Okay, that's what we did in 6. And then now we're going to go in reverse, where we're given information about the sample and we're trying to determine information about the population. Okay. And that's what this top paragraph here says. We're working backwards. Don't worry about this little t here for a second. That will be explained. Okay. So in that search, and sampled 35 of those videos, calculated the mean salary, is shown in the dot plot below, or dot plot here. Here's the 35 samples. And we see that we've got sort of a right skew kind of going on, where the majority are sort of in 0 to 35,000 or something like that. And then you start getting some individual data values that are getting significantly higher. Okay. But it was determined that the mean yearly revenue for the sample is 70,106. So on average, in our sample, the average yearly salary was 70,106. So it would be about here, 75,000. So it'd be somewhere around here. Okay, so that would be our X bar. 70,106. The standard deviation, okay, was 82,188, which is quite big. And remember what standard deviation means. It's on average, how far from the mean are each of these data values. So on average, the distance of all of these values from this mean, or the typical distance, is 82,000, over $82,000, which is quite big. Okay? Just some other information you can see here. We've got the poverty line in the United States, which is at about $12,760. So we're about, so 25,000 there, 12 and a half, we're somewhere about there. That's the poverty line. $12,060. What's the average wage in the States? It is a little over $50,000, $51,916. So we're somewhere around there. So this would be U.S. mean wage. Just to give you an idea. And remember, our average of the sample was $70,000, so that's pretty significantly above the U.S. The mean average. So that would seem to suggest right now that, yeah, make a living. Okay.
Is the U.S. minimum wage still new? Because it's not our population, but it is a. Because we're looking for the population mean for YouTubers, but the U.S. minimum wage is still a minimum wage. Is it still?
Yeah.
Like, can it still?
Yeah, but it would be like mu US, where we're looking for mu YouTubers. So do you believe it's likely the true mean YouTuber salary is exactly the same as what we got in our sample? No. Why? What's the main explanation? Why? What happens if we took another sample? Would it be identical? No, it would be a little bit different, right? And then it might be above. Another sample might be below. Another sample might be below again. Another sample might be above. Okay? That's called sampling variability or sampling variation. So no, because of sampling variation. And remember, sampling variation. Different samples produce different results. Thinking of the problem, like that's sort of the big explanation. Can you think of somewhere else in this problem where there'd be bias? What's that? Yeah, because remember, we didn't sample, like we sampled YouTubers that made videos of their yearly salary. If you're making $1 a year, do you think you're going to make a video of your salary? Probably not. Okay, so there's potential bias there that there is bias because those who made videos of their average salaries of their real salaries. But they had on these salaries. So that leads us, whoa. What? On these salaries. Oh. Keeps popping up that page to delete. Likely had high mean salaries there. That's the best I could do. So that would lead to an overestimate of the population of the YouTube salaries. Okay, so creating a confidence interval. So remember, and I'm just going to write this. Confidence interval equals the point estimate plus or minus the critical value, which is the number of standard deviations away, or because we're going from sample to population, we call it standard errors. Critical value times the standard error of the statistic. So what's our point estimate? Well, the only thing we have to use is the average from our sample, right? Bless you. So it would be 70,106. plus or minus, and remember we called it Z star. And that was the number of standard errors away from the mean. And that was dictated by whatever the confidence level we had. If it was 95%, we had 1.96. If it was 99%, we'd have to calculate it, but we know it'd be a little higher. If it was 85%, we'd have to calculate it, but we know it'd be a little bit lower. And then the standard error we would get by using this. The standard deviation of the sample, okay, that's what S, little s means. Remember, that's standard deviation of sample. So it would be, what was it? 82,188 divided by the square root of the sample size. And I'll continue this on the next page. Okay. So let's say we are told, so we've already done this, we are told 95% confidence. We already know that this is 70,000. 106, plus or minus the number of standard errors away at 95%. Well, early on in the year, we said 2, but now we can be a little bit more precise and say 1.96 times whatever that worked out to. So this is going to work out to, I'm just going to go straight to the answer. $56,213.69 at the low end to $83,998.31 at the high end. So that's our confidence interval. Okay. So remember, an arrow there. That's where we got the 1.96 from. So that's what we would have done, because that's what we did when we were dealing with proportions, except there's an issue. Okay? We don't know the true standard deviation. We can only use the sample standard deviation. Okay? So because we're using the sample, because we don't know the actual standard deviation, there is going to be some extra uncertainty involved. And we have to somehow account for that uncertainty. Okay? Remember, when we did confidence interval of a proportion, we used the normal curve, which you see here is the black. To account for the uncertainty, we need a curve that's a little bit wider. That captures a little bit more. That allows for the extra uncertainty. That is called a t-distribution. Okay? So we're actually not going to be using a normal curve. We're going to be using a t-curve, which is a little bit wider than a normal curve. Well, it depends. It depends on something called the degrees of freedom, which I'll talk about in a second. But a t-curve or a t-distribution is wider. Well, is wider. Yeah. Well, what? Well, it will when we talk about hypothesis tests, because we're gonna do t-tests. Like instead of a z-test for proportions, we're gonna do a t-test for means. Okay, because we use a t-curve. So the width captures the extra uncertainty, because we don't actually know the population standard deviation. the T-curve can change depending on the degrees of freedom. How do you calculate the degrees of freedom? You take the sample size minus 1. So remember, n is the sample size. And if you look at some examples here that I've given you in blue, red, and green, the smaller the sample size, the wider the T-curve is than the normal curve. The higher the sample size, that means the degrees of freedom are going to be higher, it gets close to a normal curve. Okay? So if we have like a sample size of 200, our T-curve would look very, very close to the normal curve. There'd be some uncertainty there, but notice that increasing the sample size decreases the uncertainty, right? See how it all meshes together. So degrees of freedom measures how precisely the sample standard deviation estimates the population standard deviation. And like I said, the higher the sample size, the more precisely we can estimate the population standard deviation, and the more our T-curve approaches normal. So because we're using a T-curve now instead of a normal curve, we don't do a Z star as a critical value, we do a T star. Because that standard deviation, remember, that's the number of standard errors, right? But remember, with T-curves, they're going to be a little bit higher because they're a little bit wider. So it's not, so at 95%, if it's normal, then it's 1.96. If we're talking about a proportion, if we're talking about normal. But if it's a T-curve, it's going to be a little higher because that curve's going to be a little wider than the normal distribution. So it tells you how many standard errors and it determines the confidence level. Or conversely, the confidence level determines our T star value, our critical value. Okay? So just recall for a Z interval, which is based on the normal curve, we used a critical value of 1.96 for 95% confidence. For a T interval to capture 95% confidence, we need to figure out the critical value, but we know it's going to be higher. Higher because the T curve is wider than the normal curve. And on this direction on certain. Okay, so how much higher? Well, if you remember, if we're given the confidence level, that's the same as the area in the normal curve. Okay? If you remember if we're dealing with normal curves, if you were given the area, how did you find one of the values below? We did inverse norm. Okay? But because it's a T curve, we do inverse T. which is another function on your calculator. So for 95% confidence, okay, remember, if it's 95% confidence, we're trying to find either this value or this value. Because these are going to be the same, right? This is just going to be negative, this is going to be positive. But they're both going to be the same values. And you can see here, it already tells you what it's going to work out to. But remember, this is 95% here, this is 2.5%, and this is 2.5%. So I can find this one here, because remember, on I know some of you have a fancier graphing calculator where it says middle, left, or right, okay? But whereas the standard TI-84 always goes to the left. So I'm given this area is 2.5%. I want to find this value, and whatever, it's going to work out to be negative, but then I just change it to positive because it's telling me the number of standard errors. So if you did that, inverse T, you would see you would have to enter the area, okay? You would also have to enter the degrees of freedom. Remember, that's sample size minus 1. So it'd be 35 minus 1. That's where we get 34 from. And you would get 2.03, which is in fact higher than when we did a confidence interval for proportions, calculating the critical Z value. Okay, because it allows for that extra uncertainty. So it's just a slightly different formula to calculate the confidence interval for a mean, because we're using T. The point estimate is still the point estimate, or still our average from our sample, which is 70,106, plus or minus T star, which we calculated above, instead of for 95% confidence, it's 2.03, times the standard error, which remember we calculated by doing sample standard deviation over square root of the sample size. So the one that we did before, that's what we thought we should have done when we were working with Z intervals, right? This is what we actually have to do. Okay, so don't get confused between the two. And then when you get this, you're going to get the actual confidence interval at 95% confidence. 41,904.61 to 98,307.39. That would be our confidence interval. And then, of course, to conclude, we are 95% confident the interval we just calculated which was 41,904.61 to 98,307.307. $307.39 captures the true mean YouTubers. Yeah. Probably not. But they are, well, maybe I shouldn't say that so quickly, because they are kind of, I know when we did standard deviation and mean and median things early in the year, they were pretty picky on units.
You lost it?
Yes. Yeah. If it's a dollar amount. Okay, not all means are going to be dollar amounts. Okay, so that's kind of the long way of doing it. But now, just like we did with proportions, there's a shorter way where we don't have to use this. Our graphing calculator will do it for us. So let's look at this problem one more time and do a full state plan do conclude. So state, well, estimating through mean YouTuber salary at 95% confidence. Plan rate a one sample, and it's not Z interval because Z interval uses a normal distribution. We're going to say one sample T interval. Sorry, estimating the true mean, and I'm going to just put a mu there, just so I can save a little time. Remember, it's mu that we're estimating. That's the population mean. So we're going to calculate a one sample T interval for mu if conditions are met. And there's three conditions again. There's random. There's 10%. And then I'll talk about the third one in a second because it's just a little bit different. It's not large counts. So random, well, if you go back to the question, the 35 videos were randomly selected. So the videos were randomly selected. We were also told at the beginning that there were lots of, what did it say? Found hundreds of videos. So we would assume that 35 is less than 10% of all YouTube salary videos. Because it said there were hundreds. Now, if you remember back to Unit 6, which could be challenging, in order to use the T distribution, well, actually, in order to use a normal distribution back in Unit 6 when we were answering questions about means, we used something called the central limit theorem, where if your sample size is big enough, your distribution is going to be normal. So if you're told that it's normal, or it's a T distribution in the question, that's great. But the large counts, sorry, large sample, not counts, the sample size has to be greater than or equal to 30. What's that? Well, no, it's going to be a T distribution. A large sample means it's going to be, we want it to be a T distribution. Yeah, that's what this does. Because remember, a t-distribution is like a normal distribution, except it's a little wider depending on the degrees of freedom. The sample size dictates how wide it is, right? So we let the sample size sort of take care of the curve. It's still going to be a normal curve. So the sample size of 35 is greater than or equal to 30. So we're good. That means that we can proceed with the do step, which in this case is under tests again. It's a t interval we're going to do. It doesn't, remember with z intervals, it was one sample z interval. It's just t interval on our graphing calculator. So if you go to the do phase, oh yeah, nice. Do, and you go to stat, scroll across to tests, and if you scroll down, I believe it's number 8, it said. Yeah, t interval. So we're doing a t interval. And then when we hit that, first of all, just always highlight stats, okay? Because it's stats that we're doing. And then it'll change the display, okay? And then you'll see everything that you need to put in. So you want to put this, because we're putting the stats in. So X bar is 70,000. $188. The standard error, or sorry, the sample standard deviation was,
70,000, yeah, one.
did I have it wrong? Do I have it wrong? 70,006, sorry. Thank you. 70,006. The standard deviation, well, that's where I got the 188. 82, 188. Your sample size is 35, and your sea level is 0.95. So 7106, 82,188, 35.95. And you see we get it to the nearest dollar. So we get $41,873. So $98,339. And then, of course, the conclusion would be the same. So it was pretty close to what we did when we did it longhand. What did we get? What did we get there? 41,904 or 905 if we rounded it to 98,307. Okay, just because of rounding, that's why it's not going to be identical. So then our conclude would be the same as we did when we did it longhand. We are 95% confident. The interval 41,873, 98,339 captures the true mean YouTuber site. But again, just to sort of keep in mind that this is going to be critical. The way this was collected may not have been great in the first place. It caused a lot of bias because we just looked at the videos. ideally, I mean, you'd want to get all the, can you, does anybody know that? Can you access? Or is that private information? Can you access anybody's YouTuber salary? I would say no. So I don't know how they would get that information unless the YouTuber like publishes it themselves. Yeah, which is what basically what we did here. Okay, yeah. But there must be way like, yeah. Hard to say. Okay,